Yes, yes,
Iron
very
Man,
simple.
Batman, Spider-Man, and
Spider-Man?
Flash.
Oh,
That's
no.
it.
Yeah, the
And also
Homestay
oh,
brother, the Flash.
Loki. Also
Loki.
FS color.
Loki.
Loki, yeah, he was nice. Very handsome.
Oh, Loki, yes, okay.
Very, very, very
And
handsome.
Sherlock, I don't know the
Yes, Sherlock.
Ah, Sherlock, yes.
Yes.
the actor.
I like this TV show.
Daniel
I like it very much.
Good.
But waiting for so
Ah, too long!
yes,
Too long!
too long.
Too
Maybe
long!
3 years was finished.
And they said the movie is bad, not very good.
What movie?
I like the movie.
Is it? It's not.
Sherlock Holmes
Sherlock
Just
Holmes.
prefer it's not good than before.
Ah.
Do you think it's a new Sherlock?
I like Sherlock the movie and Sherlock BBC.
Yes.
Yes, BBC one is very good.
BBC one's very good.
Yeah, very handsome. Sherlock.
Yeah.
Very
It
handsome,
is
yes.
very popular in
And his
China.
Yes.
face is very long.
Yeah, and he's very, is he tall?
Yes.
He's kind of tall, yes.
Yes. Very famous in China.
Yeah, I'm waiting for the next episode.
Yes, it's
Alone.
next year.
Next year?
Next
Oh.
year. Yes,
No
it's
idea.
last year it said this year.
Yeah.
And this year it's become next year.
He'll be old then.
Yes.
Not handsome anymore.
And his face is much more longer than
Yeah. Okay.
But he's coming Doctor Strange maybe this year.
I
Hmm?
don't know.
Yeah, I think Marvel's Doctor Strange. I think it is Sherlock.
Oh really?
Yeah.
Doctor Strange will be the same actor.
Yeah, yeah.
So what?
Doctor Strange is coming, I think, in Marvel's.
Is
this
America or BBC?
No, Marvel.
Marvel.
You know Marvel, like
Captain America.
I know.
you know. Yeah. So you're saying it's the same actor?
Yeah, it's the same actor.
是那个长
But Jim Moran is better than Sherlock Holmes. Like,
I like him.
我告诉你
Yeah.
这种
I like him.
Yes, Loki. I like
Loki,
Loki.
like him.
And Captain America.
And Captain America,
handsome.
yes.
Very strong.
tall.
Tall and handsome.
Tall and handsome. Maybe one day you will meet them.
Yes.
One day.
Maybe one day.
I
When you are a famous physicist.
Yes.
Yes.
No.
Maybe they need help with physics and you can help them.
Yeah, no.
No.
And my best friend, she likes Captain America very much.
Yes.
And for her birthday, I give her a picture book.
Picture book of Captain America?
No, it's not a real. It's
Yes.
original Marvel.
Oh, a comic book.
It's like this, the picture
Yeah.
from the movie.
I understand. Yes, 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 yes.
The very
Yes, yes.
sent me nearly 15 euros.
Yes.
50
50. Yes. Yeah.
to give her.
Yes.
And she just said thank you and nothing. Bye bye. And never give you a present. And never give you a present.
Terrible. Okay, we'll have a look at simple circuits. Nobody likes Deadpool then?
I like.
Handsome.
Yes.
Really?
But he can
I
ugly.
think it's just like funny.
He's funny, yes, yes. Okay, simple circuits. Ooh.
There a video. No, not a video. A GF about how the superpower go outside. Everybody's flying just as the spectacular.
Yeah.
What?
I'll find that. Okay, simple circuits. Got that?
Yes.
Okay. Okay, so a circuit is a path in which the electrons follow from a voltage. You know, I don't think you do. If you want to write parts of it down, you can. I'll read it anyways. So, an electric circuit is a path in which electrons flow from a voltage or current. Electric current flow in a closed path is called an electric circuit. The point where those electrons enter is called the source. The point where they leave is called the return, or the ground. So that's really it. I don't think you need to write this definition down. The key thing is that you understand what I mean. And the picture might help. This is a circuit. Look, because you have a source. Can you see that? The source. What's wrong?
Nothing.
Alright. You know what I mean by source?
Yeah.
Like
Power
source, like for EAP, source.
Yeah.
So it comes from here and goes all the way around and back, and that's called closed. Yeah. So it goes around and it's called closed because this switch here, if you open this switch, then it's not closed, and the electrons, they don't move around. So I think the most important words are circuit. Circuit is this, and here is the source, and it's also closed, meaning like one circle. Can you at least make note of those keywords? Circuit, source, and closed.
Another picture.
If you like. This is a picture of a circuit.
If it's not closed, it's not circuit.
Yeah, I guess not really.
To write what?
Keywords. Circuit.
Okay, I draw a picture.
So an electric circuit has to be closed for something to be called an electric circuit.
Yes.
Yeah, maybe open circuits too.
Yeah. I guess you could have an open circuit, but then nothing flows.
Isn't it like a complete circuit is when it's closed?
Yes. Complete. Yeah, yeah, yeah. Okay.
No.
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 You're drawing the picture, yeah?
Yes, and then a wonderful
A wonderful picture. More beautiful than Captain America.
Yes.
Yes.
No. What is return or reverse?
Yeah, source is when the electrons come out, and return is where they go back in. But you can just call all of this a source. But if you want to be technical, where they come out is the source, and where they go in is the return.
The
Yeah.
source, single dry what?
Oh, this is single dry cell. A battery. Yeah, now these words,
Source is setting off.
yes. Now these words are important also. Do you see these words here? Source, look, that's here, source. Load, that's like the light bulb. Conductors, that's the wires. And then control, that's the switch. So I need these words.
Control.
Control, switch.
Control.
Control, like control, alt, delete. Control.
Yes.
Yes.
What is the load? Light something?
Light bulb.
B-U-L-L-B?
B-U-L-B.
L-B.
Yeah, light bulb.
What is already come out?
Source.
And can mean?
Return.
Come out is source,
Yeah.
not just battery.
Well, you see, some people call the whole battery the source. That's okay. But if you want to be technical, it's source on one end and return on the other end. But if you say source for the whole thing, that's okay. Yes. So beautiful.
No, can you see the small word?
No, I can't. I'm not a superhero. What are you asking me?
Plus is go in?
We'll get to that later. It's
How will it
complicated.
come out?
Well, it's complicated because remember, the current goes one way and the electrons go the other way. So the electrons come out here at the minus.
Come out at minus.
The electrons come out at minus.
Yes.
But we say the current comes out at positive. I know, we talked about this last time. If the electron goes from A to B, we say the current goes from B to A. I know, it's a terrible situation, I know. It's Benjamin Franklin's fault. Yeah.
Last time is last year.
No, last
Long time
class.
ago.
You were sick, remember?
Yeah.
Yes.
So I can't remember anything.
I know. Did you watch the video?
No.
No.
Not yet.
Okay. It was the lesson, it was the last lesson, wasn't it?
Yeah.
Yeah. Yesterday.
On Monday.
On Monday, okay. Can I continue, please?
Yes.
Yeah, okay. So, of course, we can't draw a beautiful picture every time. We can't. We haven't got time to draw beautiful pictures. So instead, we use special symbols for the drawing to make it clear. So, the symbols, Amanda, Grace, and you were on your phone as well.
You started talking, I thought.
As soon as I start talking, you stop. No. Of course, we can't draw beautiful pictures every time. We need some symbols. So here are the symbols here. So if we want to draw a switch, we use this symbol. A cell is this symbol. A battery is more than one of these. This is a lamp, a voltmeter, an ammeter, a resistor, a variable resistor. This means you can change the resistance. And this is a motor, like a car motor, something that turns. So you need to draw these carefully, please. They are very important symbols. Yeah, you got all the symbols?
Yeah.
Yep.
What is
Great.
last one?
Motor, it turns, like for, where's the fan? There. See it in the corner? Motor means it turns. Electric motor turns, like in the fan. You know what I mean?
No.
Okay.
I will translate.
Please. Okay, can I continue?
No, you said draw nice. Not
Okay. Draw nice, not too nice.
Oh.
M-O-T-O-R. Motor.
Ah.
You know it?
Yes.
Good.
Uh-huh.
You know it, Amanda?
Yes.
Yes.
滑东西.
No, motor.
Yes, this is motor in Chinese.
I know,
You
but
can
in English.
You can translate to your next Chinese
Next Chinese student, yes. Yes. Okay, continue. Not yet. Yes.
Only 1 hour and a half.
All right.
Okay.
Continue. Yeah. Okay. Now, um, just some vocabulary. So in this, Amanda and Grace, please put the phone aside. Thank you. So, some vocabulary. You see these lamps? When they are together like this on the same wire, we say this is series. But when they're in two opposite wires like this, we call this parallel. Please write these words down and draw the pictures.
Can you just show me a symbol just for a second?
Okay. Which one?
But lamp is the symbol.
That's because it's a picture.
Yeah.
They were trying to be beautiful.
Yeah.
No, they should really have a cross, I know. But in fact, you can do it this way too if you want.
No, I was just confused.
Oh, yeah. You drew these? Yeah? Show me. Okay. Did you? Okay.
Beautiful.
Yes, indeed.
I need more coffee.
Yeah, me too.
Or chemistry.
Oh yeah. 1 or 2 hours.
2.
It was one and then something happened.
Yes.
Yeah, something happened too.
Yes.
Oh my god.
Yes.
What happened?
Karen, you should ask.
Nothing
They
happened.
should have asked.
Just learning.
They should.
You just told me to ask and I'll try to be a good class
Because
representative.
in our timetable it's only one
Class
period,
representative
but
who
then
care
she
about
kept
class.
saying like we had to do like twice like to the whole class plus the health and science students, and then like we were like, oh, do we have to say such? So then I went to ask her, like, oh yeah, you have to, like, but we haven't like gone for the second period for like the whole time. So last week was our first, so now she said like from now on we have to go for the class. So
Tough break. Tough break.
So we have 1 more hour chemistry.
You can thank them after class. Okay, can I continue? Yeah? Yes?
It usually be 3 hours, I can go home.
Yeah, it's like
Look, I'll take care of him later. Okay. Now, English time. So we just need to be careful with some English points here. So one battery is not called one battery. We call it a cell. So for example, well, I don't have one here, but when you have one, it's not called a battery, it's called a cell.
You need a cell?
Not just a cell, a cell. So I don't want to hear really, oh, this circuit has one battery. You shouldn't be saying that. You should be saying it has a cell.
Like, when you use battery then?
We'll get to that shortly. Relax. Relax, you'll see all. Okay, so one battery is not one battery, it's a cell. Got that? 2 or more cells is a battery. So if you have 2 of these, then you call it a battery. So, cell is the singular and battery is the plural. You know? Man, men, mouse, mice. Cell, battery.
So you can use cells and a cell both, or just a cell?
We would say like there is. Yeah, you could say one cell or a cell. Yeah, but you don't say one battery. You no.
A cell. Forget about battery or you.
hang on. You're confusing me. Right. So we have one like this. Okay. You can say one cell, or you can say a cell. That's fine. Okay. If you have something like this, this is called 2 cells.
One battery. No.
A battery.
Battery.
what if there's
Or you could say 1 battery. But my point is here you don't say,
One battery.
this is what I mean, you don't say 1 battery here. So what I'm trying to say is a battery is 2 or more cells.
So if there is 4 cells with 2 batteries,
No, 4 cells, you could still say is 1 battery.
so this is singular itself.
Yeah, single is
Single is a cell. Yes. When there's only one, it can only be a cell, never a battery. You need to have 2 to make a battery. Is that okay?
Yes.
Yeah.
Just remember one is special, another is just called battery.
Yes. Okay. One is special and the other is battery. Okay. So I have a 3-volt cell. Right. This is okay, yes? I don't have to write this down if you understand the English. I have a 3-volt cell. Right or wrong? This is right. I have 2 3-volt cells. Therefore, I have 1 battery. Right. I have 3 3-volt cells. Therefore, I have 1 battery. Right. I have 2 batteries. Wrong. Please don't say this. Don't say this, please. You have 1 battery. You don't have 2 batteries. I have a 3-volt cell. Therefore, I have 1 battery. Wrong.
I should say 1 cell.
I have 1 cell or a cell. Yeah. Please don't say this. I'm simplifying the English here, but it works. Yeah. Now it gets complicated because what would you call this? A battery or a cell?
Cell.
Well, there's only one, isn't there? So you should call it a cell. But what you can't see is if I open this, in fact there are many cells inside of it. So it's actually a battery. So this is what I mean. The English can get a little complicated here. I can call this a battery because I know there are many cells inside of
But
it.
it's a cell phone, not a battery phone.
I don't know if that cell has anything to do with this cell. I think that might just be a coincidence. Yeah, it's a cell phone, not a battery phone. I'm going to have to look that up in the dictionary because that's quite interesting now that you've said it.
Some logic.
There is some logic there. I'm going to have to check that after class. Well, hey, what are you talking about? Hey, what's wrong?
Let's talk about cell phone. They have a song.
I'm continuing.
Yes.
Oh, payphone.
Yes. No paper.
I'm
No,
a
no, no.
That's my song.
Oh, Bruno Mars?
No, the Maroon 5 one.
No,
Maroon 5.
no Maroon 5. Another one.
Another one.
You could call me on my cell phone.
Oh, lightning.
No Maroon 5. No people.
I'm continuing now. Okay. So let's have some rules now. So the first one is when you have a series. So do you remember a series is when it's like this, 1 line. So maybe there's a ammeter here, and maybe there's an ammeter here. So this is this is I1 maybe, and this is I2, for example, something like this. And let me draw that again. Sorry. Resistor, and maybe here is an ammeter, and here is an ammeter, and this has an I1, and this has an I2, and this is an R1, and this is an R2, and then here is a voltmeter, a V1, and here's a voltmeter, a V2. Okay. Current is constant. So what I mean here is if it's in series, the I1 at the start equals the I2 at the end. You need to write these rules down, they're very important. Yes. Resistance is additive. So what I mean here is the total resistance is R1 plus R2. So if I just go back here for one moment, you could replace this with one big resistor whose resistance is R1 plus R2 if you wanted to. Okay. Voltage is different and additive. So if the voltages would usually be different, the total voltage adds together. So if I just go to the picture for one moment, here is a V1, can you see that? And here is a V2. If I put another voltmeter here, around both, here would say V1 plus V2. So they add together like this. Okay?
What do you mean by voltage is different?
Well, the voltages will be different usually because the resistors are usually different, you know, because what's the point of having them the same in the circuit? There might be a reason, but they're usually different.
It depends on resistance voltage.
Yes, exactly. So they'll be different. Continue. Next one. Battery. Plus with minus makes an increase. Plus with plus or minus with minus makes a decrease. So what I mean is, imagine that this battery here, let me draw it, is 3 volts, and I put it together with another battery. I see, look, my English, I'm terrible. I should be saying cell. I have a 3 volt cell, and I put it together with a 3 volt cell, and together I make a battery. The voltage in total here is 6 if you put the plus with the minus. Yeah? But if you have something like this, let's say this one here is a 12, and then this one here is a 2, then when you put them backwards the wrong way, it's like you only have 10. So if you put a plus with a plus, you know, the wrong way, it makes it smaller, not bigger. Do you get what I'm saying?
Mm-hmm.
Yeah? So a plus with a minus makes it bigger, and a plus or a minus with a minus makes it smaller.
The same sign.
Signs decrease. Yeah. Yeah. Continue. Now it's the same page, don't worry. A situation is a bit different when they're parallel. So by parallel I mean like this. So here I have R1, and here I have an ammeter, I1, and then here I have an R2, and here I have an ammeter with I2, and then here I have a voltmeter, V1, so V1, and here I have a voltmeter, and here is V2. Okay? That's what you picture. So, current is different and it adds. So, what I mean here, I'll put another ammeter here. So this is I1 and this is I2. What you get on this ammeter is I1 plus I2. Oh no. Okay, no, it's okay. Don't panic, it's okay, it's okay. It's still okay. So the I's add together when they're parallel. Got that? Continue? Yes? Now, the way the resistance adds together is a little bit complicated. It's the reciprocal that adds. So what I mean here, if this is R1 and this is R2, and you want to make it like a big resistor here, it's not R1 plus R2. Okay? If you were to replace this with one big resistor, oh, ugly. Hang on. My colour's gone. Pen. If you were to replace this with one big resistor, the resistance is not R1 plus R2. It's not that. The calculation is like this. You must calculate it from this formula. So you solve for R. So you know you can say R equals 1 over this if you want. So anyways, the resistance adds together in this strange way. Yeah? Yes? Okay. Voltage is actually constant, which is interesting. So if you look at my picture, here V1 actually will be the same as V2, and if you put a big voltmeter around everything, it will also be the same. That the voltage here and here and here is all the same in parallel. So the voltage is constant in parallel, which I think is interesting. Yeah. Because you wouldn't have necessarily guessed that. That should be equal. Yeah. Yes? Continue? Battery. We'll study this later. So when the batteries, or the cells, when the cells are in parallel, the way to add them together is strange. It's difficult, yes, it's not easy to do, that's a different lesson. Okay, so don't worry about the cells here.
Is it in our course?
Oh yes, it's not that difficult. It's not a simple rule like this.
Yeah.
This lesson is simple circuits. Yeah. Okay, continue.
Yes.
Right. So we've got a picture here. This is the cell, and now look, you don't need to write it down because you have the picture. The voltage of the cell, can you see, is 5 volts. Can you see that? And you have a 1, 2, 3, 4 ohm resistor. And we want to find all the currents. Okay, so I'll draw it and then you can draw it. So it looks something like this. In the middle, you've got, what did I say, 5 volts. And then it goes here to, yeah, is a question? Yeah. And here is 2 ohms. Here is 3 ohms. And here is 4 ohms. Okay. Have you drawn that? Yes? Continue.
Yeah.
Now, please watch carefully. Don't panic. Watch carefully. Are you watching? You're not watching. Right, you watch carefully. So
Okay.
what I can do, I can redraw this. 1, 2, 3, and 4. And I can put the battery around this way. Hang on, let me think carefully. Sorry, I should draw in my current. This is the positive side. I never said that. This is the positive and this is the negative. So the current goes this way. Now, can you see why this picture is the same?
Because it's sealed.
Yeah, well, look, here the current goes from the battery and then it splits here, doesn't it? It goes down and right. That's the same as this picture. It goes along and then it splits. But I think it's easier to have it on the outside. And you can draw this like this. And then it splits. And then it goes like this. So what I'm trying to say is this diagram is the same as this. What one is up here? 1, 2, 3, and 4. So this will be 1 and 4. And then this will be 2 and 3.
If we can calculate it that way, we don't have to like change it. It's okay.
Well, this is good because now we can add the resistors together. Can I go down a little bit to here? So on the top, this is like a resistance of 3. Yeah? And then on the bottom, this is like a resistance of 7. And this is a voltage of 5 volts. Do you see what I'm doing? I'm simplifying this problem. Continue? Continue down? So now we have to add these together. 1 over R equals 1 over 3 plus 1 over 7. So 1 over R equals 10 over 21. So R equals 2.1 ohms. So now I have this picture. So if I have my triangle, VIR, what does the I equal? V over R. So the I will equal 2.1 divided by 5. So that's 0.42 amps.
5 divided by.
Uh-oh. 5 divided by 2.1, thank you, that is 2.38 amps. Yeah? Yes? Now, we have to go backwards now. So look, here the current is how much? 2.38. So if I go back to this picture, how much is it here? 2.38. Yes? 2.38. Now, is the current here and here the same? No, this is I1 and this one here is I2. But what should I1 plus I2 equal? 2.38. You see what's going to happen? Now I need to find another equation. Okay. Are you okay with here, 2.38? Because it comes from this picture. But here the current splits. We call this one here I1 and this one here I2. They are not the same. They are different. You can know that I1 plus I2 should equal 2.38. If I go back here, I'm using parallel. I1 plus I2 is the total current. Is that okay, Grace?
Yes.
Yeah. Now, look, we can use this triangle again. See? What's the OR here? 3. What's the V?
V equals
Five.
I,
5.
oh.
Because back
That's
here,
parallel, yes, yes, yes.
parallel, the V's are the same. So if the V we know, and the, the V we know and the OR we know, what's the I?
V,
Well, actually, the I is just equal to V,
Over.
V over OR, 5 over 3. And the other I is equal to 7 over 3. Now, we need to check. If I add these together, do I get 2.38? Let me see. 5 over 3 plus 7 over 3 is 4. I did something wrong. No, what did I... hang on, sorry. Sorry. Right. I1 is 5 over 3. And I2 is 5... No, I is V over R.
Yeah.
5
Over 7.
over 7. Let's try this again. 5 over 3 plus 5 over 7. Hey, 2.38. So we're happy.
yes.
Yeah? So I know the I1 and I know the I2. So if I go back here, where was my I1? It was here. Now, is here the same as here?
Yes.
Yes.
Same.
So here it is 5 over 3. So that's 1.667 amps. And here it is 5 over 7. Oh, what I'm saying is, so he is, the current here, here, and here is the same. Yeah? And then what's the current here and here?
Plus together.
Yep, which should be 2.38. So here is 2.38 amps. So now finally, if I go back to the picture at the start, here the current is 1.667, and here the current is 0.714, and here in the middle the current is 2.38. So now I have all the currents. We're cool? You don't know, there might be another question.
What?
There's not though.
Yeah.
But there might be. You didn't know that. I'm trying to make it smaller so you can see everything. You would be nicer to me if I looked like Captain America. Of course, yeah. Tall and handsome and strong. Well, at least I'm tall.
Yes.
Yes.
So much all.
Like 1 from 3.
No, but isn't the character very short? The actor.
Yeah, I don't know actually.
I think it's short, I think.
Is he? Alright.
Like airman.
Like who?
Airman.
Who?
Iron Man.
Iron Man. It's Iron Man.
My favorite.
Iron Man?
Yeah.
Okay.
Alright.
Homework.
Bye bye.
He's 183.
Oh, nice.
Oh my goodness.
Fantastic evening.
Ruined. Do you watch Agents of Shield?
I don't actually. I watch.
You should.
I watch Arrow,
Yeah.
Flash,
Right, right.
Supergirl,
Super. Yeah, it's nice.
Colony.
Gotham.
No, Gotham sounds terrible. What else do I watch? I don't
Game of
know.
Thrones.
Huh?
Game of Thrones.
Oh no, I don't watch that. Or Shield.
Sherlock.
And Sherlock, yes. I really like Flash and Arrow and Supergirl and Colony. Flash is great. So's Arrow.
I haven't
And
seen.
so's Supergirl. Supergirl's a good show actually. You watch Supergirl?
No.
Oh, you should. It's good. It's good. Okay. Can I close this now?
Yeah.
Do you have this, Amanda?
Yeah.